Good afternoon, everyone. I hope I am audible. So, let's start the class. Okay, let me share my screen. So, so today basically we are going to talk about the building materials. Okay, what building materials are used in our construction? These things are repetitions actually of your fourth semester only. So, what building materials are used in a construction? You know this, like they are how many types? Concrete, steel, wood, and masonry. These are your. We remove this. So, what are the basic what building materials are used in your construction? They are your concrete, steel, wood. Let me. Okay. So they are what? Concrete, steel, wood, and masonry. Each material has different properties. These, you know, that there are different. Obviously, concrete will have different properties. Steel will have different property. Wood will have different property. We are going to come later. We are going to talk in the next class maybe about the advantages, disadvantages of all the different materials like these steel, wood, or you can say timber used for our construction. Okay, so but the choice like which one you are going to use, the choice in which type, whether you're going to use wood or you're going to use steel. Concrete is required, you know that, but in some places with the help of wood also you construct some things, right? Some structures are built with the help of wood also. Timber we use basically. So that choice of material for construction, that is based on what? That is based on your cost and effectiveness to resisting the loads and stresses acting on the structure. So basically, when we are choosing any structure, any material, what we have to keep in mind, we have to keep in mind the cost and effectiveness to resist the loads. Okay, to resist these loads we have to, such that depending upon the type, right? Suppose you are making a structure which is required or which will need to carry huge, or you can say a greater amount of loads. Okay, greater loads. So in that case obviously you will have steel for that, steel and concrete. But if you want if your structure, if you desire that your structure is such that not necessarily they are going to take much of loads, some amount of load, the standard amount of load they are going to carry. So in that case you, depending upon that, you can use another material also like wood or etc. Obviously the cost effectiveness also you have to keep in mind depending upon your economic condition or how much you will be investing on that particular structure. Okay, so as a structural engineer, okay, these will be. Okay, so engineers have to deal with the clients and help them decide on the type of material they are going to use in their projects. Okay, the manufacturing of building materials is a well-established and standardized industry capable of providing a reliable supply of height. The production of structural grade this. Okay, basically what we are talking in this, like sometimes you can make the cost effectiveness of those structures which are made up of which are made up of your natural materials. Like it can be rubble masonry. When we talk about rubble masonry, it is like of hard rocks or stones, greater stones. So these are natural materials. Suppose you are making a wall. That wall is made up of your you can say naturally available big stones or gravels. Okay, so in that case, our cost effective, our economy is less here. We can use that. Okay, so basically, your building materials can generally be divided into two categories. What are they? Natural building material, these which are stone, wood, and man-made building material. Man-mades are what? Concrete and steel. These two are your man-made, and the natural one is your stone and wood, like this I told you. Okay, so both categories usually require a certain level of preparation or treatment before they are used in structural applications. Okay, so the first, suppose we talk about the concrete, you know that your concrete is used in all the types of structural members, right? So most important one in your structural analysis is your concrete. When you talk about materials in your construction, you will the first one that comes to your mind is that should come to your mind is your concrete. Okay, so what is your concrete? This is nothing but a mixture. It is a mixture of your cement, aggregate. We have talked about this in the previous classes, I think. Like concrete is made up of what? Cement, cement. Then we had what? Aggregates. That can be your what? Aggregates. Okay, aggregates can be either fine aggregate or coarse aggregate. It can be fine aggregate, it can be coarse aggregates. Okay. Then we had what? One another one was your water. For your concrete, these are required. Water, cement, aggregate, and your aggregate can be fine or coarse aggregate. So therefore it's a standard practice for concrete suppliers to provide materials, properties, and test results for each concrete patch. See here some of the important points are here like fresh concrete can be poured into formworks to take any shape to form and take time to harden into a stone-like material. It takes up to 7 days for concrete to reach the majority of its strength. That means the maximum strength is attained in your after 7 days of the concrete after it is poured. When your concrete is poured after the 7 days, it will attain its maximum amount of strength. Okay, and will need a special attention to carry to avoid cracking or reduction in capacity. Concrete is very versatile and is we go to material for applications that require a combination of strength and durability. For example, concrete is an excellent material for building foundation. Obviously, we know for building foundation where the weight of the material meets the ground, this will require to carry a load and also durability to withstand the contact with the surrounding soil. Basically, if we say concrete, we had talked before also about that, and also in your IS4 also you'll get some of the theory parts there also. I'll show you. And steel bars, for steel bars concrete is very strong. What is written here is that when exposed to compression, obviously the steel bars, why they are required? Because our these steels are very much good in tension. So obviously concrete is good in compression. Concrete cannot take the tensile stresses and that tensile stress, and therefore, since this cannot concrete cannot take tensile stresses, so therefore, what happens? You will see cracks. That is why you see cracks in your any beam or somewhere. You see slight cracks in your beams. Why? Because concrete is good in compression and it can take compression. But when it is taking compression, one time will come when your this beam is going to bend somewhat like this. No? Your straight beam is going to, due to this load, when it is taking compression, and then a time will come when it will start showing these cracks. Why? Because it is now, it should take now the tension. It should be taking the tensions, right? Since there should, but concrete is good in compression only, it is not good in tension, and therefore these cracks are visible. Okay, and as a result of which it fails. So therefore we use what? We use our steel, which is good in our tension. Steel is going to take the tension, concrete is going to take the compression, and as a whole these two combined together, RCC, reinforced concrete cement, okay, they are going to take what? The tension as well as your compression from the loads. Okay, so these things I told you now. Steel is one of the strongest, yeah. I think I was talking with you people or with the seventh semester. Yeah, with seventh semester, I think. So what is happening in steel? You will have different types of steel. It can be channel section. It can be I section. Your steel structures or steel members can be. It can be either a channel section. Diagram is wrong. Wait, I'll show you. If I take a square, that means, suppose this one, then we have this. Okay, so this is nothing but a steel member which looks like a C. So it is named as channel section. Then it can be your I section. Okay, this can be your channel section. It can be an I section, I beam section, or it can be a angle section. Angle section means like this. It is looking like a right angle, right? So like this also your angle can be like this, or if you, this can be like this. Okay, so this can be your angle section, this can be like this also your angle section. Okay, so these are different types of your steel materials, that means your steel members, okay, which are used for your different structural members. Whether the reinforcement bars, you know, that is used in your concrete structures, RCC structure. But what about in some type of steel structures where only the member is, no concrete is there? Like if you see in your bridges, above the bridges, there are some trusses made, and then again in your what to say, that warehouses, etc., you will see they are made up of steel members, right? Steel members like cylindrical pipes, steel pipes, then again angle sections, these kind of angle sections, or maybe a channel section combined together here with the I section, and then they are used to form a structure, that is your steel structures. Those are your steel structures. Okay, so another one was your wood. What wood has been used as a construction material for thousands of years, and if properly maintained, can last for hundreds of years. It is readily available and economically feasible natural resource with the lightweight, highly machinable properties. Let me see one thing. So you have what? These are your wooden structures. These are all the theory portions. Okay, actually, I should have given you the these material, and then you could have studied only. I can masonry also we had talked about in the fourth semester already. We had talked structural loads. Now coming, yeah, about structural loads also we had discussed in the last previous semester. That loads, live loads, wind loads. Let me check one thing. This is your IS 456. Okay. So here, if we see in IS 456, these you see here. Here you will get the contents. Here you have all the materials required in your construction, which are your cement, mineral aggregates, admixtures. All these are here. And regarding them, regarding these materials, what are the specifications that are mentioned in your steel book? Okay, so about admixtures, whether it be admixtures, whether it be about
We can see
reinforcements.
your, ma'am.
Huh?
We can't see your slide.
You're not able to see?
No, we are still
Wait,
at
wait, wait, wait,
structural
wait.
loads.
My screen is visible. My screen is visible. Now,
Yes, yes.
mm, okay, so in your IS code, if you go to your IS code 456 2000, you will see here in the contents itself that you have different materials based on IS 456 Indian Standard Code. You will have different assumptions and different criterias which are related to your these materials. Okay, cement, whether it be cement, whether it be aggregates, whether it be your admixtures, reinforcements, concrete grades. I think we have talked about grades also, about concrete grades. Then different all the things are mentioned here in your IS code. Let us once check about the
Ma'am, you have given these notes now.
hello,
Among these, which, hello, hello,
hello.
ma'am,
Can you
hello,
speak
ma'am.
louder? Hello, hello.
मैम सुनाई दे रहा है क्या?
थोड़ा थोड़ा बोलो तो धीरे आ
अच्छा
रहा है।
मैम, among the notes that you have given for IS 456,
हाँ हाँ।
which topic we need to print out? Which topic?
No,
There
what?
is a lot around
Which
100.
topic? You need to print out, you need to have this entire IS 456 with you. It is very important for you
It's
people to have your, because when you will be designing in your later semesters also, you will have to have different IS codes. This IS code 456, I think I have talked with you people in the last class about different IS codes, which IS code is for what purpose, what about what informations are given there. There are different IS codes. So basically, this IS 456 talks about your RCC materials, okay, testing, the specifications, whatever important things or whatever criteria are given. Those all the things are mentioned here. Like
one
if you
100.
have your concrete कब अच्छा होता है, when your concrete is good, how much should be the value, all those ranges, everything, mixed design, everything is here for mixed design, for your RCC. All this is your IS code 456. You will need everywhere this one, whether you pass out degree, you work somewhere, you will need this. If you go on the site also, you want to you are working somewhere, you will have to have your IS code, because in your IS code only you will get everything. Okay, so for this particular semester, when we are talking about RCC, you will have to have your IS 456 2000 with you. Okay, when you were
About
when
ma'am,
you had your
two
offline classes, when we had offline classes, you had to have your hard copies of IS 456 with you. But now, since we are doing online, I think soft copy I have provided. I think
yes,
IS.
ma'am, but it is about 107
Uh
pages.
huh.
So we 107 page that is up. So we need to
थोड़ा
print out all the pages. 100 page.
hello
107 page.
hello.
Hello.
Your voice is low. I don't know. I am getting low. Your voice too low. Whatever it is, I think you were. I think I heard something 100 page or something like that. Maybe you are telling that so many pages are there, but that doesn't matter. You will have to have. Basically, actually, we don't give for Xerox and all this one. You have, there is a book. That means this code book is there. IS 456 2000 code book is there. Actually, you should have that with you. We had that, and everybody should have that IS 456 code book. IS code book with you. But book means what? Code you should have with you. Xerox तो ये उड़ ही जाएगा. If you Xerox once, later you cannot use. But this, since this is very I got your chat. Do we need to print 107 pages? Yeah, you need to print. You will have, because ये लगती रहेगा. You will actually, you can order for the book also. This code, sorry, IS code 456 in book form. You will get this, so that you can use in your futures also when you're working somewhere, or you need to find out the limits, the range of values, load, how much load should be there, how to find out the space, safe load, etc. So all those things, for that, when you're working also somewhere, you will need this 456. So better you give for print that book, then that will come and it will stay with you for long. Like now, if we talk about this one, suppose about load, we are talking page number 32. You see here, this is clause number 19, loads and forces. This clause number 19 talks about all your load conditions, what should be what. Okay, like here in general design, account shall be taken of the dead, imposed and wind loads. Okay, so most of the important things are here in your IS code. So like this loads and forces here, why we are using, so that we can find out how it will take imposed loads, dead loads, wind loads, earthquake loads. Okay, and what are the effects of these loads on shrinkage, creep, temperature, etc. So, like for dead load, what is mentioned for the dead loads? Dead load shall be calculated on the basis of unit weight, which shall be established taking into consideration the material specified for construction. Understood this? So, when we are calculating, when we are designing something, you are designing a structural member. You want to find out how much dead load is going to come on that particular. Suppose you are making a residential house of a G plus 1. Okay, so when you're making G plus 1, you will use materials with that. So that materials, using those materials, you will make beams, you will make columns, you will make slabs, all those things you're going to make. So the load coming from each member, like the column, slabs, whether it be your column, whether it, okay, I'll do one thing. This is going to end. Now, what is the time? Okay, let us join. This meeting is going to end. We'll join. Take 5 minutes break and join here again in the same link. Okay.